My name is Rob Martindale. I am the Colorado Department of Transportation's Utility Program Manager out of the Denver office. Today I'm going to chat a little bit about CDOT's program as far as incorporating 38 and 75 into a project lifecycle. And so this is how we manage our utility projects that fit within our overall construction, pre-construction design and construction. So obviously utilities is one of the major branches that drives construction delays and creates a lot of headaches for contractors, but also for our project managers and others that work on our projects. But when you look at CDOT's utility engineering project data lifecycle, this is how we look at it when it comes to a clockwise starting at scoping and planning. You'll see utility coordination is the center of all of our work for utility delivery. But out on the side, you'll see design, ASCE 3822, and then on the left side, 75. And then right in the middle, you see this handoff. And there's a handoff between SUE and 38 to the construction side and capturing the as-built data during construction. And whether that's the roadway construction portion or if it's utility, early relocation utility work. But when you look at planning through SUE at 10%, we'd like to see our SUE deliverables come in at 10% design. One of the things in ASCE 38 emphasizes getting the quality SUE data in early enough for your designers to leverage it in their design. And for us, a 30% design is a major milestone for us. And so if we have the SUE data early, our designers have the ability to work with it and know what kind of impacts they may have for their design. If they have a quality level B gas line that's showing up at 10% design, maybe they can shift a design around to avoid it. And so that is one of the pieces that utility coordination leverages this SUE data as well when they're talking to utility companies. The better the information on a facility and the better explanation our coordinators have with our designers about why we're having to relocate something or why we avoided something is a major piece for us when it comes to coordination. So when you look at 30%, we're leveraging SUE up to 30%, looking at a conflict matrix, and I'll go through this in more detail in a little bit. And then test hole determination, like Tom said, we don't want to go out and just create Swiss cheese out of the road. Let's look at, specifically where those test holes need to be and then leverage those within the conflict matrix. Looking at early relocations around 90% roadway design is what we try to achieve. We'd love to have everything relocated early. It's not always a possibility, but that's something that at least we're ready for, and we know going into construction what utilities are relocated early, what still needs to happen during construction, and that just gives a better picture to our contractors of what the risk is for them during construction based on everything that we've provided to that point. But at that handoff, when we're done with the SUE data, we leverage that SUE data through construction. We leverage it in the field. We allow contractors to see this data. And then as relocations happen, we then have a database built around the 75 standards where we can capture all that information. And then going into our operation and maintenance periods, we definitely love to have this data during that period so that when we start back over during planning, we have a clear picture of what's still on the roadway, what's been abandoned, or what we're looking at for the next SUE project. And Tom talked about records, and Teo did as well. So the better records you have starting out with SUE, the better your product's going to be, and maybe the cost or return on investment will be there, be seen, because you have a database with accurate utility records. So I won't go into a ton of detail on 38 and quality levels because Tom did that, but we do leverage 38 standards in our state, and I'll talk about this in my next slide, but we have a state statute around SUE, and so leveraging 38 is definitely is part of our state statute, which we're one of the only states that has a statute around subsurface utility engineering. But knowing how this utility information can be obtained, what technologies can be leveraged to obtain quality level B information and Tom spoke about all the different ways you can get to quality level B and all the different tools and technology you can use. So understanding what tool you need for the job is certainly important. And as an agency, I would encourage you to understand what those geophysical tools are, because if you write a scope of work and just say use everything in the kitchen sink, you're going to end up with a very expensive SUE project. So understanding what technologies you need and maybe what quality levels you need is certainly an important part of scoping a project for an agency. So in Colorado, when you look at SUE, again, we have a state statute that's requiring SUE when it meets 4 criteria, and these are the criteria on the screen. Construction involves a construction contract with a public entity is the first bullet. Horizontal construction only, not vertical. We have an excavation limit requirement, which says exceeds 2 feet in depth and a contiguous 1,000 square feet on the surface, or involves any utility boring. So that boring could take place of just surface excavation and subsurface disturbance. And then it must be a design by a PE professional engineer. So those 4 criteria, all 4 have to be met in order for, by state statute, a SUE project to ensue. They're called SUE required projects in our state. And we have a best practices that has been issued by the Underground Damage Prevention Safety Commission. It's a 15-member commission that issued best practices on how agencies should approach SUE and understand SUE, so that when they have a project per state statute, then they can go forth and deliver it that way. So we have some other tools that we use in our toolbox within CDOT. Again, we leverage the best practices to help educate why SUE is required for our projects, whether it's internal stakeholders like designers, project managers, or if it's external to our consultants and those that are required to assist us with the SUE project. We have a master scope of work that we use and leverage it for project-specific scopes, where we can take and modify it to a specific project when we need to. We have a SUE request form that we use to solicit proposals from SUE vendors. We don't self-service SUE within our agency. We just don't have the expertise or the equipment to do that, so we outsource all of our SUE work. Having contracts for SUE services is certainly important, so you have methods to obtain SUE services easily, so you don't have to go through a long procurement process in order to do that. And then having a CAD workspace with quality levels, with 3D modeling, drainage and utility modeling within your CAD system is certainly something that I would encourage. CDOT has that, and it's very helpful to standardize what's expected from your SUE vendors if you say, here, use our workspace for that, for those deliverables. So this is an example of CDOT's project limits and how we scope. Again, we'll define our project limits. We'll scope out A, B, C, and D quality levels and maybe even test holes early on, and then tighten that up as we go. But this is just to emphasize, for the different quality levels, we may focus quality level B on certain areas of the project and require C and D outside of maybe a resurfacing project, where you have an intersection improvement project that requires a lot of quality level B and A, but then outside of that, maybe it's just resurfacing and striping, so then you could maybe go with C and D at that point. So just understanding your needs and scoping that is certainly important. Providing that into a subsurface utility engineering checklist for proposals, solicitation for proposals. That way, this checklist for us walks us through defining what the quality levels we need for the specific project. It also accounts for that we looked at the state statute and that we checked the boxes on that as well. So it's this good documentation, and again, you can leverage that with multiple SUE vendors for proposal if we need to. Again, contracting at any level, whether it's local agency or state agency, just having contracts in place. Some of the mechanisms that we use at our agency, we use non-project specific contracts, and ours are called utility engineering support services. So they include utility coordination, construction management, and SUE. They're not just for SUE. We do have some SUE-specific contracts, and so total we have 6 of those, and you can see that we have a high dollar amount for our contracts, so that we can use those over a 5-year period to obtain services. Other ways to get SUE services in your project is a project-specific scope, adding that master scope and modifying it for an RFP for maybe design build, or we have a lot of design build or CMGC type projects, which are alternative delivery projects other than design bid build. And so having the ability to insert what you want from a utility engineering support services, including SUE and coordination and construction management, is important to be able to do that. And then we have some general engineering design contracts where we have support for engineering design, but also SUE is built into that scope as well. So we have multiple ways to get to a SUE consultant through our contracting. So bringing this back to what Tom was talking about, the different types of deliverables that come out of 3822 that weren't in 02, are examples here that are in Chapter 5 and some of the exhibits of the vaults that we see coming through the SUE reports, or scoping LiDAR scans of an interior of a vault, like you can see on the right-hand side in Figure 5-7, and LiDAR scanning of storm drain lines within 5.8, and then again just maybe pictures of documenting the conduits coming in and out of the vault and the size of those being depicted on your plans. Certainly important, certainly good notice to contractors too. So these are just examples of how far you can go, or how the minimum you could have for documenting a vault. We've looked at multiple geophysical tools within the toolbox of our SUE vendors. This is just an example of a CDOT fiber optic conduit that is running along Interstate 70 out near Grand Junction, Colorado. And this is an interesting install. We had HDD under a roundabout at an interchange. Then we had an open trench of this conduit, and then you can see in the upper left we had another HDD installer, a bore underneath the canal. And so traditionally you look at quality level B, and a lot of ways to achieve that, and a lot of SUE companies will use electromagnetic locators to tone that, trace it, along with their records to verify that this is where it is and they have confidence in that quality level B information. So you can see there's a yellow line there that traced this on the surface and was able to say, okay, horizontally and the record show and physical handholds on top, an engineer would say, yeah, this is a good quality level B fiber optic line. What we wanted to do is show just another tool. This is a gyro mapping tool where we inserted it inside an empty conduit that ran parallel to the live conduit fiber optic. And the green line shows inside profile, 3D profile of the actual conduit. So we ran that through. We knew we were going to be deep under the canal, and you can see that it's around almost 26 feet deep under the canal there. And then where it comes out underneath the roundabout, we're at about 21 feet deep. But just, again, examples of different geophysical tools. These are both quality level B, but you have maybe a higher quality level or confidence in the elevation of the green line versus the yellow line. And so it would require a lot more test holes to find the green line if you're starting with the yellow line. So just, again, this is an example of maybe considering what geophysical tool that you need. If you need the exact 3D profile of the line, then there is options for that. If you don't, then you could use something that maybe costs less, and then you can achieve it by following up with test holes. I think Tom spoke to this. One of the changes in 3822 that we really like at an agency is the above ground inventory. So we have pole inventories. This is super helpful for identifying the additional utility owners on these above ground poles and then where they drop off and go subsurface, because you can see this line on the right, pole number 2 has electric, telecom, and a fiber telecom on there, and they all sometimes, or they all, demarc at different locations and go underground. So just knowing that from a utility coordination standpoint, being able to talk to all those owners and make sure they're accounted for in the conflict matrix, because maybe all these poles need to go away during construction or an early relocation. And so making sure you have everybody accounted for is certainly helpful, and 3822 has done a good job of guiding Sioux companies in what should be delivered. And as you can see, this is a PE certified, and that falls in line with 3822 as well. Having CAD standards at our agency, having quality levels built into our workspace, we use MicroStation. So this is just an example of a plan, utility plan that's included in our plan sets for in the quality levels being identified. Again, this is helpful for anybody looking at the data for the utility data, seeing that gas lines are quality level B, that you have a water line that's quality level D. So, if you need to make that water line into a quality level B, for whatever reason, when you're working through design, then, you may have to send a Sioux company back out, work a little harder to bring the geophysical tools to up the quality level on that. So maybe once it's determined, it shifts that quality level D line 5 feet to the south, maybe because it was D and now it's B. And so that is an important piece, because if you go out to construction with a water line that's a D quality level, and then all of a sudden it is 5 feet further south and the design didn't account for that, that's where you start to see some delays in contracting and construction. And so just keep those things in mind. Those are things that we look at and our coordinators look at, and designers, as everybody's working together to try and achieve a design that can be built by a contractor. And then as we move through our life cycle, you look at what I had, we're now at about 40%, 50% design, where we're looking at those test holes. We have the dark black lines are the proposed storm drain line that's being installed or being proposed, and we're looking at the conflicts now, and you can see all the flags that are coming up, the different colors, the different types, and where possibly we should obtain test holes. On the left, we're taking test hole data, we're taking the existing utility data and combining that within MicroStation to build a clash detection model, 3D model within our drainage and utilities program. Running all this through helps us create a conflict matrix that really pinpoints the relocations or the avoidance or accommodating utilities in place. And so it's extremely important to use this life cycle to build all the way through, talking and coordinating with utility companies what we've done so far to either avoid them or there's no way to avoid them now we have a relocation. But sitting down with a utility owner and saying, we've done everything we can, we've looked at design changes, we've used all this geophysical information to gather your location, so we feel confident that we've done everything we can, now we're going to have to look at a relocation. And so it's important for us as an agency to be able to justify where we're spending those dollars, maximizing our designs and maximizing the utility effort. So we're back to the life cycle. We're now through our design. We've identified the conflicts. We've identified relocations that must go forward. So we're looking at early relocations at 90%. We're handing this off now from Sioux to 75 to construction. And so all that Sioux data, all the proposed design, all that information for CDOT is now pushed out to the field for relocation work. So on the left, you can see we take our data, we move it out to the digital platform and send it out in the field as we're relocating, we're collecting these as-built. You can see the little dots on there as far as the test holes that we've achieved during construction. A lot of our successful projects that we've had, we have contractors that will leverage this electronic utility data, and they'll keep track of their test holes. They'll verify that, when they found a test hole on a water line a year ago, and then all of a sudden the project needs to locate that water line again, and excavation locates them out and they're in a different location, it can resolve itself much quicker if contractors have confidence in where they found utilities versus where maybe one call has shown them before they excavate. And we've seen efficiency gains in contractors being able to pick up their production rates, resolving excavation locates that are mismarked. Avoidance, if there's mismarked utilities, then it creates a damage issue, and then they're out there digging on locations that are not accurate. So managing the data during construction, and that's one of the things that 75 is very good at, bringing this data out, using it, and following the construction activity all the way through, and not just newly installed utilities, but abandoned utilities as well. So again, Tom hit on the 75 standard. It is a companion document to 38, and that's how we use it here at CDOT. We use that 38 data through design, and then it's handed off to construction, and then 75 allows us to now take that data and apply some attribute information to it and store it in our database. On the left, you'll see here that's our CAD environment where we have the utility information. We have new design. We've pushed it to the digital platform on the right, which is now out in the field, allowing construction management and inspectors to leverage this data in the field for relocation. One thing that 75 does well is talk about 3D data capture, what's expected, what you should do to set it up, and the attributes you should capture. But just showing, this example within 75, here's where points of change along the vertical, maybe it's a water line that's running horizontally straight, but vertically it's diving down 10 or 15 feet. We have water lines that do that. We have other lines and comm lines that do that as well. So trying to capture those locations where they bend horizontally and vertically is extremely important for your database. And then the attribute information within 75 is very comprehensive. You look at all the different attributes they suggest and have options for are very important. You look at the amount of survey information that they look for and accuracy. You can really build a lot of attributes into your database when you set up something around 75. And structuring it this way and standardizing it this way makes it a lot easier for all your projects if inspectors are going to work on capturing this data, and having a uniform set of attributes really does help. And so this is an example of how Colorado has set up our database for data capture. You look at the two screenshots on the right, you'll see the far right, you'll see details like the open cut with flow fill, the utility depth, that it's a low pressure 8-inch line, it's PVC, it's Excel gas. We have a permit number for that was issued by CDOT to install that in there. There's some survey codes that allow our data to move back and forth from the GIS platform to CAD. And then also what's important in the attribute table in 75 is capturing how it was collected. What's the accuracy. You'll see in here our pedigree data is shown, the type of GNSS receiver that was used, the date, the horizontal precision, the vertical precision, and all that information that validates the observed location for that particular gas line. And then documenting with pictures and photos and things like that and sketches that also support what is going on during construction. So one of the other things that CDOT does is we require utility as-built through our permitting process. And so you'll see on the left we have a permit, and that permit requires a special provision to capture utility as-built during construction. Plus, we have a 625 construction specification that allows for construction surveyors to capture utility as-built information during construction. So we have a database that filters all of the different swim lanes of data coming in, whether it's utility permitting, whether it's utility relocations during construction. We want a mechanism to capture that data and publish it in the same place. So, I mean, everybody knows historically utility infrastructure is very poorly documented during construction, and it's the best time to capture utility data is when it's exposed, and it's new, and it's fresh, and you can get really accurate 3D information on it. And so it's not always easy to capture during construction. Maybe it's something that you can capture afterwards with a tracer wire or other means of accessing it, but the goal for us is to try to capture it during construction when it is open and exposed, and then leveraging the guidance by 75. Again, this is just showing on the left, there's some storm drain lines in one of our projects that was left in place, so documenting the out-of-service utilities is certainly important. On the right is just a gas line relocation. There's a green storm drain that's new that's going in up above it. And so we wanted to verify that the elevation of that new gas line would not conflict with the proposed elevation of that new storm drain. So this is an early relocation of a gas line, just an example of being able to field verify that when the gas company installed that new line, that you're not going to have a second conflict coming back. You know, we had an old line that's running down the middle that is in conflict, and there's nothing worse than installing a new facility and still having a conflict. And so being able to field verify, clear that so that you have confidence when the contractor comes through that you're in good shape. And then finally, construction observation and reporting. So gathering all this data, that at some point maybe you have questions about what happened on a certain day or during a certain install. So if you have construction management and inspection, please use observation reporting along with the data capture so that you have some other documentation that goes along and supports what was going on. So this, again, the black line is the existing gas line, and we have these two new green lines that are going to be tied together with a couple 90-degree bends. But just being able to document that, have that geospatially referenced, so our reports are embedded in our database so that you can reproduce those and go to the project area and then click on it and be able to bring those reports back up at any given time. So I want to thank you guys. I know I went through a lot, but our life cycle has certainly been successful on many big and large projects within Colorado as far as managing good quality existing data all the way through design, handing it off, taking it through the 75 process of documenting and through construction. And I'll emphasize that at CDOT, over the years, we have seen a lot of effort in utility coordination and maybe even investigating the existing utilities. And then we hand it off for construction without any oversight, without any mapping. And we found that the contractors have delays, have trouble during construction because not everything is identified during the engineering side. And so being able to continue to see that through construction is certainly important. So I want to thank you all. I appreciate the time today, and I look forward to questions during the panel session. So thank you.